Every day, you unlock your phone with your face. Netflix recommends your next favorite movie before you even search for it. Banks detect fraudulent transactions in seconds. Cars can recognize traffic signs, avoid accidents, and even drive themselves. Have you ever wondered how machines can perform these incredible tasks? They weren't programmed for every possible situation, they learned. Welcome to the fascinating world of machine learning. What is machine learning? Machine learning is a branch of artificial intelligence that allows computers to learn from data instead of relying only on fixed instructions. Imagine teaching a child to recognize a cat. You don't write thousands of rules. Instead, you show many pictures until the child begins recognizing cats naturally. Machine learning works in a similar way. Instead of memorizing rules, computers discover patterns from examples and use those patterns to make predictions or decisions. AI versus machine learning. Many people use artificial intelligence and machine learning as if they mean the same thing, but they don't. Artificial intelligence is the broader concept of creating machines that can perform tasks requiring human intelligence. Machine learning is one method used to achieve that goal. Think of AI as a large tree, while machine learning is one of its strongest branches. And within machine learning lies an even more powerful field called deep learning, which we'll explore later. History of machine learning. The journey of machine learning began decades before smartphones and modern AI. In 1950, British mathematician Alan Turing asked a revolutionary question: can machines think? His famous Turing test laid the foundation for artificial intelligence. In 1957, Frank Rosenblatt introduced the perceptron, one of the earliest machine learning models inspired by the human brain. Progress continued over the following decades, but limited computing power slowed development. Everything changed in the 2010s. Faster computers, massive datasets, and powerful graphics processors allowed deep learning systems to outperform humans in image recognition, speech recognition, and strategic games. Today, machine learning powers search engines, recommendation systems, autonomous vehicles, healthcare, finance, and many of the AI tools we use every day. Why machine learning matters. Machine learning is no longer a technology of the future, it's already part of our daily lives. Hospitals use it to detect diseases earlier. Banks rely on it to identify suspicious transactions. Online stores recommend products based on your interests. Navigation apps predict traffic before you begin your journey. Businesses use machine learning to understand customer behavior, farmers use it to improve crop yields, and scientists use it to accelerate research. Behind many of the smart technologies we interact with every day, machine learning is quietly making better decisions, faster than ever before. How does machine learning actually work? Imagine you're teaching a child to recognize apples. You don't give the child a list of complicated rules. Instead, you show hundreds of pictures: red apples, green apples, big apples, and small apples. Over time, the child begins recognizing apples without memorizing every detail. Machine learning works in exactly the same way. Instead of learning from experience, computers learn from data. The more high-quality data they receive, the better they become at recognizing patterns and making predictions. Step 1. Collecting data. Every machine learning project begins with one essential ingredient: data. Data can come from almost anywhere: photos, videos, customer purchases, weather reports, GPS locations, medical records, or even the clicks you make while browsing the internet. Without data, machine learning cannot learn. In fact, data is often called the new oil because it powers modern AI systems. Step 2. Cleaning the data. But there's a problem. Real-world data is rarely perfect. It may contain missing information, duplicate records, typing mistakes, or incorrect values. Before a computer can learn, this messy data must be cleaned. Think of it like washing vegetables before cooking a meal. Better ingredients lead to better results. Step 3. Training the model. Once the data is ready, it's time to train the model. During training, the computer studies thousands, or even millions, of examples, searching for hidden relationships. Every mistake helps the model improve. It adjusts its calculations again and again until its predictions become increasingly accurate. This process is very similar to how students improve by solving practice questions before an exam. Step 4. Testing the model. After training comes testing. The model is shown completely new data that it has never seen before. If it makes accurate predictions, the model is ready for real-world use. If not, developers improve the data, adjust the algorithm, and train it again. Machine learning is a continuous cycle of learning, testing, and improving. Machine learning pipeline. Let's bring everything together. Every machine learning system follows the same basic pipeline. First, collect data. Then clean it. Train the model. Test the results. Finally, use the model to make predictions. This simple process powers many of the intelligent systems we use every day. Supervised learning. The first type of machine learning is called supervised learning. In supervised learning, the computer learns using labeled data. Imagine showing the computer thousands of pictures already marked as cat or dog. By studying these examples, it learns how to classify new images correctly. Supervised learning is widely used in email spam detection, medical diagnosis, credit scoring, and house price prediction. Unsupervised learning. Unlike supervised learning, unsupervised learning receives data without labels. The computer must discover patterns on its own. It groups similar information together based on shared characteristics. Companies use this technique to identify customer segments, detect unusual behavior, and analyze shopping habits. Reinforcement learning. The third type is reinforcement learning. Instead of learning from labeled examples, the computer learns through trial and error. Every correct decision earns a reward. Every mistake receives a penalty. Over time, the system discovers the best possible strategy. This method powers self-driving cars, advanced robotics, and AI systems that master complex games like chess and Go. Comparing the three types. Let's compare the three learning methods. Supervised learning learns from labeled data. Unsupervised learning finds hidden patterns in unlabeled data. Reinforcement learning improves through rewards and penalties. Although they work differently, all three aim to help machines make smarter decisions. Popular machine learning algorithms. You may have heard the word algorithm many times, but what does it actually mean? An algorithm is simply a set of instructions that helps a computer solve a problem. In machine learning, different algorithms are designed for different tasks. Some classify emails as spam or not spam. Others predict house prices, recommend products, or detect fraud. You don't need to memorize every algorithm today. What's important is understanding that algorithms are the engines that allow machine learning models to learn from data. Machine learning in everyday life. Whether you realize it or not, machine learning is already part of your daily routine. When YouTube recommends a video you'll probably enjoy, machine learning is analyzing your viewing habits. When Netflix suggests your next series, it studies your watch history. Google Maps predicts traffic and finds the fastest route. Banks detect suspicious transactions in real time. Online stores recommend products based on your interests. Behind the scenes, millions of machine learning models work every second to make digital experiences faster, smarter, and more personalized. Advantages of machine learning. Machine learning offers incredible advantages. It can process enormous amounts of information far faster than humans. It improves accuracy by learning from experience. It automates repetitive tasks, allowing people to focus on more creative work. It helps doctors detect diseases earlier, assists businesses in making smarter decisions, and enables scientists to analyze complex data in record time. When used responsibly, machine learning has the potential to improve lives across nearly every industry. Challenges and limitations. Despite its power, machine learning is not perfect. A model is only as good as the data it learns from. If the data is incomplete or biased, the predictions can also be inaccurate or unfair. Privacy, security, and transparency are becoming increasingly important as machine learning systems influence more decisions. That's why responsible AI development isn't just about building smarter machines, it's about building trustworthy ones. The future of machine learning. The future of machine learning is only just beginning. In the coming years, it will transform healthcare, education, transportation, agriculture, scientific research, and space exploration. AI-powered assistants will become even more capable. Personalized education could help every student learn at their own pace. Medical systems may detect diseases earlier than ever before. While no one can predict the future with complete certainty, one thing is clear: machine learning will continue shaping the world we live in. Machine learning isn't magic. It doesn't think like humans. It learns from data, recognizes patterns, and improves through experience. From recommending your favorite videos to helping doctors save lives, machine learning has become one of the most influential technologies of our time. And this is only the beginning. The people who understand this technology today will be better prepared for the opportunities of tomorrow. Thank you for watching. If you found this video helpful, please like, subscribe to EduSpot, and turn on notifications so you never miss our next educational documentary. In the next episode, we'll explore deep learning and discover how computers can recognize faces, understand speech, and create astonishingly realistic images. Until then, stay curious, keep learning, and I'll see you in the next video.